Okay, this is your second review video for the second half of the unit, objectives 4, 6, and 7. I've grouped the problems, roughly speaking, according to objectives, so that if you feel like you're pretty good with objective, 7, then as soon as we're done with objective 6, you can stop the video. You don't need to do objective 7 if you don't want to. Or if you feel like you're good with objective 4, we'll fast forward to objective 6. Right? Orient yourself within the video according to the topics that you're needing to practice. Because this is a review video, my recommendation is with each problem, as we identify which one we're going to be doing first, pause the video, try that problem on your own, and then restart it when you have either an answer or are stuck and need a tip as to what to do next. One of the two, but restart the video when you're ready to check your work. And then pause the video again on the next one, restart the video when you're ready to check your work, etc., etc. Skip around in the video to find the topics that you need to practice. Okay? So objective 4 is up first. Objective 4, we were looking at simplifying, specifically using the angle addition and I should say sum and difference rules for our angles. And so we had sine of alpha plus beta, sine of alpha minus beta, the cosine of alpha plus or minus beta, and tangent of alpha plus or minus beta. All of those laws are in your notes. I would highly recommend taking a look at them because unfortunately you can't just add the two angles willy-nilly. You do need to make sure you've actually applied your addition or subtraction rule. Okay, so the first one we've got here is sine of 200 degrees times sine of 40 degrees plus cosine of 200 degrees plus cosine of 40 degrees. Go ahead and pause the video, give this one a shot, and restart it when you're ready. Okay, so as we look at our angle addition laws in objective 4, this one looks the most like our cosine of alpha minus beta rule. Now for cosine alpha minus beta, these two are reversed. And so initially here our problem is actually backwards, but that's okay. Nice thing about plus is I can just switch them and I'm good to go. If there was a minus in between, well, I could still switch them as long as I factored a negative out. If I factored the negative out, that would bring my cosine to the front. But again, because this is addition, I can just switch them. Whoops, that should say cosine, I'm sorry. Cosine of 200 degrees, cosine of 40 degrees, and then plus sine of 200 degrees, sine of 40 degrees. Okay? And so we're now in our cosine form, so cosine of alpha minus beta equals the cosine of alpha, cosine of beta, plus sine of alpha, sine of beta. And so these here are my alpha, this is my beta, and so reversing that addition law, sine of alpha minus beta would be sine of 200 minus 40, which is equal to the cosine of 160 degrees. And then you always want to double check, and if this is something that we can actually evaluate, you would take that next step, and we'll do a couple of those today where we can do a little bit more. This particular one, I don't know what the cosine of 160 degrees is, and so I just leave it there. Okay? Okay, number 2 is up next. Go ahead and pause the video, give this one a shot, and restart it when you are ready. Okay, this one is also the cosine rule. We see up here cosine of 7 pi over 12, cosine of pi over 4, minus sine of 7 pi over 12, sine of pi over 4, which looks most like the cosine alpha plus beta rule. So this would be alpha and beta, because cosine of alpha plus beta equals the cosine of alpha, cosine of beta, minus sine of alpha, sine of beta. And so reversing that rule, this would be cosine of alpha plus beta, which is 7 pi over 12 plus pi over 4. And all of that's over root 3. Okay? 7 pi over 12 plus pi over 4. If I found a common denominator to add those, Let me zoom in here. I just realized that's a little small. Okay. So if I found a common denominator in order to add those, this would be 7 pi over 12 plus, and 4 as a pi over 12 would be 3 pi over 12. So this is 10 pi over 12, or if I reduced that, 5 pi over 6. And so this is cosine of 5 pi over 6 all over root 3. Okay? Well, the cosine of 5 pi over 6, we do know how to evaluate that one. Cosine of 5 pi over 6 is the pi over 6 angle in the second quadrant. So since we're in the second quadrant, sine would be positive, meaning this one's going to be negative. So that's cosine. And then what's the cosine of pi over 6, or in this case 5 pi over 6? The cosine is root 3 over 2. Okay? And then if I do negative root 3 over 2 divided by root 3 is the same thing as multiplying by its reciprocal, 1 over root 3, which gives me negative 1/2. Okay? Okay, next up we have this third one. Go ahead and pause the video, give this one a shot, restart it when you are ready. Okay, so as we look at our angle addition laws, this one looks the most like sine alpha minus beta. One small thing is that in the sine alpha minus beta rule, neither of them have a 4 in front, but that's easy enough to take care of. I can pull that 4 out. I should say factor it out. And what I'm left with then is 4 times sine of alpha cosine of beta minus cosine of alpha sine of beta, which matches again the sine alpha minus beta. This here would be my alpha, beta, alpha, beta. Okay? And so then reversing our sine alpha minus beta, we would have sine alpha 4 pi over 15 minus beta pi over 10, which does simplify again like the previous problem if we found a common denominator here. So that would be a denominator of 30. So 8 pi over 30 for my 4 pi over 15, multiplying top and bottom by 2. And 3 pi over 30, multiplying top and bottom by 3 here. This is 5 pi over 30, or if I reduced 5 pi over 30, pi over 6. Okay, I do know what the sine of pi over 6 is. Sine of pi over 6 is 1/2. And so this answer is 2. Okay, next up, go ahead and pause the video, give this one a shot, restart it when you are ready. Okay, this particular one looks the most like the sine alpha plus beta rule. In fact, it's pretty much directly from it. Alpha, beta, And so reversing my sine alpha plus beta rule here, we would have sine of my alpha, 112 degrees, plus my beta, 54 degrees, which 112 plus 54 is 166 degrees, which I do not know how to evaluate, and so that would be my answer. Okay, 2 more with our simplification rules here with our addition laws. Go ahead and pause the video, give this one a shot, restart it when you are ready. Okay, this one, as we look at our angle addition laws, looks most like tangent of alpha plus tangent of beta. We've got our alpha, beta there, matching our tangent alpha plus beta rule. And so reversing that, tangent of my alpha is 126 degrees plus beta, 189 degrees. Right, which when I add that, 126 plus 189 is 315 degrees. Let me do a quick double check of that addition. 5, 1, 1, 3, yes, tangent of 315 degrees, which I can evaluate. We do know what the tangent of 315 degrees is. 315 degrees is a 45-degree angle in the fourth quadrant. So since we are in the fourth quadrant, cosine would be positive, so tangent would be negative. And then this is the 45-degree angle in that quadrant, so what's the tangent of 45 degrees, or in this case 315? It would be 1, so our answer is -1. Okay, and then last but not least, for this set of problems, go ahead and pause the video, give this one a shot, and restart it when you are ready. Okay, so this one looks most like tangent alpha minus beta. There's our alphas and betas there. And so if I were to reverse that rule, tangent of my alpha, 7 pi over 5, minus my beta, pi over 15. I can combine this by finding a common denominator of 15. So this would be 21 pi over 15 if I multiply top and bottom by 3. Which is 20 pi over 15, or if I reduced that, 4 pi over 3, which I can evaluate, whoops, over 3, sorry, over 3. If I evaluated this, 4 pi over 3 sits in the third quadrant, so tangent is positive there. And this is the pi over 3 angle in the third quadrant, so what is the tangent of pi over 3, or in this case, 4 pi over 3? And that would be √3. Okay, so that's simplifying using our angle addition laws. The other thing that connects, I'd say, directly with Objective 4 are these types of problems. So the last 3 that we will do for Objective 4 here, which is when you are given an angle measure and you are asked to find its exact value, but it's one that we don't inherently know. Like, I have no idea what the tangent of 285 degrees is, or cosine of 75 degrees, or sine of -105. And so what we have to do is to be able to figure out, well, what two angles, when I add them or subtract them, give me 285, 75, or -105. Because if I can find those two angles, then I can use my angle addition or subtraction properties to expand and be able to evaluate this and find its exact value. Okay, so go ahead and pause the video, give this one a shot, and restart it when you are ready. Okay, the most challenging thing I would say about these ones is the wide variety of ways you can actually solve these problems. Because there obviously are not just two angles that add to 285 or two angles that subtract to 285. There are actually quite a few that you can use. And so I'm going to walk through one way, but it is not necessarily the only way. So if you walked through it a different way, that might be fine. If you don't get the same answer, which you should, if you don't get the same answer, take a picture of it, email it, ask where you got off. We'll check your work and respond, right? For me, tangent of 285 degrees is, or I see it as 240 degrees plus 45 degrees, which are two angles that I do know I can evaluate. Using my tangent alpha plus beta rule then, we have our tangent alpha plus tangent beta over 1 minus tangent alpha times tangent beta. And so then evaluating these, which I can, 240 degrees is in the third quadrant, so it's going to be positive. And this is the 60-degree angle in the third quadrant. So what's the tangent of 60 degrees? √3. Tangent of 45 degrees is 1 over 1 minus tangent of 240 degrees, we said was √3 times 1, which means just √3. Okay? Okay, go ahead and pause the video, give this one a shot, restart it when you're ready. Okay, again, different ways of doing this one. There isn't just one right method, right? Let me do a quick double check. How did I do this one? I did 135 minus 60. That's right. So 135 degrees minus 60, which are two that I do know I can evaluate. Again, not the only potential combinations, but the two that I used. And so this is cosine of alpha minus beta. Okay, so cosine of alpha minus beta is cosine of alpha, so 135 degrees, times cosine of beta, so cosine of 60 degrees. And then remember with the cosine ones, the sign changes. So since this is minus, we're going to have plus as we expand it. Sine of alpha, sine of beta. Okay. Sorry, one second. Okay, so I can now evaluate that. Cosine of 135 degrees is the 45-degree angle in the second quadrant. So it is negative, because only sine is positive in the second quadrant. And then the cosine of 45 degrees is root 2 over 2. Cosine of 60 degrees is 1/2. Plus sine of 135 degrees, again 45-degree angle in the second quadrant, so it's positive because sine is positive in the second quadrant. And then root 2 over 2 because it's the 45-degree angle. Sine of 60 is root 3 over 2. And so then simplifying this, we have negative root 2 over 4 plus root 6, right here, root 6 over 4. Which simplifies to negative root 2 plus root 6 over 4. Whoops. Went off the screen a little bit there. Okay, last but not least, for objective 4, go ahead and pause the video, give this one a shot, and restart it when you are ready. Okay. So sine of negative 105 degrees, when I did this one, I did sine of negative 135 degrees plus 30 degrees to give me my negative 105. So negative 135 plus 30. Again, not the only option. That's what I did. And so this is sine of alpha plus beta. So we've got sine of alpha, so my negative 135 degrees. Cosine of beta, so 30 degrees, plus my cosine of alpha, negative 135 degrees, sine of beta, 30 degrees. Okay? Which is something that I can evaluate. Negative 135 degrees is the 45-degree angle in the third quadrant. So tangent is positive in the third quadrant, so this would be negative. And sine of my 45-degree angle would be root 2 over 2. Cosine of 30 is root 3 over 2. Cosine of negative 135 degrees, again the 45-degree angle in the third quadrant. And sine of 30 is 1/2. And so then this simplifies to negative root 6 over 4 minus root 2 over 4, which is negative root 6 minus root 2 over 4. Okay? And that was objective 4. Okay, next up we have some objective 6 extra practice problems here, and I've spun in a couple of other ones from some prior objectives just to give us a little bit of extra practice distinguishing what strategies we might use in each particular instance. This is in your notes, the one that was printed as objective 5 according to the notes packet, but it matches with the objective 6 homework assignment. So it's the one that you did on Tuesday and Wednesday of this week as your assignment for Tuesday, Wednesday, of last week. Tuesday, Wednesday of last week. Okay, so we're going to be solving for x so that x is an element of 0 to 2 pi, so x is between 0 and 2 pi. It can equal 0, it cannot equal 2 pi. Okay? First one, go ahead and pause the video, give this one a shot, and restart it when you're ready. Okay, so this one actually utilizes a little bit of an objective 4 concept here because we have a cosine alpha plus beta in here and a cosine alpha minus beta. So we're going to go ahead and use a little bit of our objective 4 there. Cosine of alpha plus beta is cosine of alpha, cosine of beta. And then if this is plus, it becomes minus sine of alpha, sine of beta. Okay, so that's expanding this guy here. And then we have minus at the back here, cosine alpha minus beta, which is cosine alpha, cosine beta. And since this is minus, it becomes plus sine alpha, sine beta. Okay. And then I'm going to go ahead and distribute the negative, and while I do that, I am going to go ahead and evaluate. I do know what cosine of pi over 6 and sine of pi over 6 are. Okay, so we have cosine x times the cosine of pi over 6, which is root 3 over 2, minus sine x, the sine of pi over 6, which is 1/2. Distributing the negative, so minus cosine x, the cosine of pi over 6, which again is root 3 over 2, and then minus sine of x, sine of pi over 6, which is 1/2. And so what we're looking at here then are like terms that can cancel in the cosines and like terms that can combine in the sines. Negative 1/2 minus 1/2 is negative 1. And then if I divide this negative 1 over, we get sine x equals negative 1. And so the question is, well, for what angles between 0 and pi, including 0 but not including 2 pi, I'm sorry, for what angles between 0 and 2 pi, including 0 but not including 2 pi, would sine of x equal negative 1? Well, sine is 0 and negative 1, or 1, on each of your quadrantals. And so the question is, well, which of those quadrantals is sine negative 1? And sine is negative 1 at 3 pi over 2. And so x equals 3 pi over 2. Okay. Okay, next up, go ahead and pause the video, give this one a shot, and restart it when you are ready. Okay, isolating our trig here, we're going to go ahead and start by subtracting this 3 over. So we have 4 sine squared of 2x over 3 equals 6 minus 3, which is 3. Dividing the 4, we get sine squared of 2x over 3 equals 3/4. And then square rooting both sides, we get sine of 2x over 3 equals plus and minus. Because remember, when you square root, it's plus and minus. And then this is root 3 over root 4, or 2. And so then the question then becomes, well, for what values would my sine equal plus or minus root 3 over 2? The reference angle for this one, what gives me a sine of root 3 over 2, would be pi over 3. And because it's plus and minus, that 2x over 3, my angle here, could equal the pi over 3 in any of our quadrants. So pi over 3, 2 pi over 3, 4 pi over 3, or 5 pi over 3. Okay, we do have a multiplier within our trig, the 2/3 here, and so you would want to take that into consideration. If it was, for example, 2x instead of 2x over 3, you'd want to go another rotation through your unit circle, and you'll see one of those a little bit later in the video. In this one, we're going 2/3 of a rotation, and so if you're comfortable looking at this and crossing off the 5 pi over 3 because you know that one's going to go away, go ahead and do so. But if you're looking at it going, well, I've got 4 answers, I'm not sure I know how to figure out what 2/3 of the answers would be, then don't cross off. Solve for x and then look at the answers you've got, make sure that they all fall between 0 and 2 pi, not including 2 pi. Okay? And so solving for x here would mean multiplying both sides by 3/2. Go ahead and write that 3/2. And so then pi over 3 times 3/2 is pi over 2. 2 pi over 3 times 3/2 is pi. 4 pi over 3 times 3/2 is excuse me, 2 pi. Sorry. And then 5 pi over 3 times 3/2 would end up being 5 pi over 2. Okay? And so in this case, we actually end up with 2 answer choices being crossed off. Both 2 pi and 5 pi over 2 lie outside of my restricted domain, and so my only answers would be pi over 2 and pi. Okay? Okay, next up, go ahead and pause the video, give this one a shot, and restart it when you're ready. Okay, so 2 sine squared 3x equals cosine 3x plus 1. We have mixed cosine signs here with a +1 on the outside, 1 squared, 1 not squared, so we're definitely going to need to do some sort of substitution here. In this case, we are going to be using our cosine squared plus sine squared equals 1 rule. Which means this sine squared here would be the same thing as 1 minus cosine squared. Okay, and then this is looking to me like it's probably going to end up being one that we're going to factor because we have a squared and a not squared. And so I'm going to go ahead and distribute and combine like terms and move this until it is equal to 0 so that I can factor. So distributing here, we have 2 minus 2 cosine squared 3x. And then you could subtract the cosine 3x and the 1 to the front, but I'm actually going to move everything on the left side over to the right because I want my cosine squared to be positive. I always like how that looks a little bit better. So adding the 2 cosine squared over, we still have our positive cosine 3x here, and subtracting the 2, 1 minus 2 is -1. And so we're going to be factoring this one. Again, for those who don't like factoring in this form, you could think of it as 2x squared plus x minus 1. And ask yourself how that would be factored. And then go back and plug the cosine 3x after you factor. And so this one we'd be looking for 2 things that multiply to -2 and add to -1. I'm sorry, multiply to -2, add to +1. Which would be +2 and -1. And again, I always recommend double checking. 2x times x is 2x squared. 2x times 1 is 2x. -1 times x is just -x, so x, and -1 times 1 is -1. And so we know we factored correctly. So substituting our cosine 3x in, we have 2 cosine of 3x minus 1 times cosine of 3x plus 1. And so then we can set these individually equal to 0. 2 cosine of 3x minus 1 equals 0, and cosine of 3x plus 1 equals 0. Okay, adding the 1 over and dividing by 2, we get that cosine of 3x has to equal 1/2. Again, adding 1 and then dividing by 2. Subtracting the 1 here, we get cosine of 3x equals -1. Which means figuring out, okay, so for what values would my cosine be 1/2? So cosine is 1/2, or has the reference angle who has a cosine of 1/2 is pi over 3. And so we're again talking about pi over 3 reference angles here. Now we only want our cosine to be positive in this one, so we're only talking the first and the fourth quadrants. Right? But then this has 3 rotations in here. We're cosine 3x, so those are going to repeat 2 more times. That's 1 rotation, so we're going to add 2 pi to pi over 3. So that'd be 7 pi over 3. 2 pi here, 11 pi over 3. A little bit more space, set some white out. Adding 2 pi to the 7 pi over 3, we're looking at 13 pi over 3. And 2 pi to 11 pi over 3, we're looking at 17 pi over 3. Okay, so 3 rotations, and so then dividing 3, my angles would be pi over 3 divided by 3, pi over 9, 5 pi over 9, 7 pi over 9, 11 pi over 9, 13 pi over 9, and 17 pi over 9. On the right over here, we have cosine 3x equals -1, so what would that reference angle be? Well, cosine is -1 at the pi angle, right, on the pi quadrantal there. So pi. And then we have, again, 3 rotations of this. So adding 2 pi to that, we'd be sitting at 3 pi and 5 pi. And dividing the 3 over then, x equals pi over 3, dividing the 3, pi, and 5 pi over 3. So quite a few answers on that one. Okay. Okay, next up, go ahead and pause the video, give this one a shot, and restart it when you're ready. Okay, so this one actually goes back to, I think it was objective 3. Let me double check that real quick. I think is where we put this in. Yes, objective 3 is where we put in this identity here. And you actually have a couple of options. One, if you wanted to, you could use your sine alpha minus beta rule to simplify this, and that wouldn't be wrong. It's a different route through it. But for those who recognize this identity, sine of pi over 2 minus x, if you look in your objective 3 notes, is cosine of my x there. In your notes we call it theta, not x, but right, sine of pi over 2 minus theta equals cosine theta. And so we can simplify there. Okay, we've got 1 sine, 1 cosine, so if I subtract that cosine over to the other side, I'm looking for where is sine the same value as cosine but opposite signs, or dividing the cosine underneath, sine divided by cosine is tangent, and since I divided the cosine out here, we're left with -1, so you could just ask yourself, where does tangent equal -1? And that's probably the route I'd recommend, but it's your choice. Okay, and so for this case, where does tangent equal -1? Well, the reference angle for for tangent of 1, the reference angle is pi over 4. And I want tangent to be negative, so what quadrants is my pi over 4 in? That would be the 2nd and 4th quadrants. Well, the pi over 4 angle in the 2nd quadrant is 3 pi over 4, and in the 4th quadrant is 7 pi over 4. Okay, 2 more here for objective 6. Go ahead and give this one a shot and restart it when you're ready. Okay, so this one looks the most like our problem up here that we started with. Uses a little objective 4 element of angle addition or subtraction rules. So this is alpha and beta, alpha and beta. So sine of alpha plus beta is sine of alpha cosine of beta plus cosine of alpha sine of beta. We have minus sine of alpha minus sine of beta is sine of alpha cosine of beta minus cosine of alpha sine of beta. That equals root 2. Okay, so I'm going to go ahead and distribute the negative here. While I do that, I'm also going to evaluate my pi over 4th because I do know that all of those equal. Okay, cosine of pi over 4 is root 2 over 2. Sine of pi over 4 is root 2 over 2. Distributing the negative, cosine of pi over 4 is root 2 over 2, and distributing the negative in, sine of pi over 4 is root 2 over 2. And so what we've got there are two like terms that will cancel, okay, and two like terms that will combine. Root 2 over 2 plus root 2 over 2 is 2 root 2 over 2. Which simplifies to just root 2. And so then dividing this root 2 over, we are looking at, well, what would make cosine of x, root 2 divided by root 2, equal 1? Well, cosine equals 1 at the 0 quadrantal, and also the 2 pi, technically speaking, but remember your domain. We can include 0. We cannot include 2 pi. And so my answer is going to be 0. Okay, last one. Go ahead and, this, by the way, is not a 1. Let me make sure that does not look like a 1. That was supposed to be a dividing line. This is just negative tangent squared 2x. Okay, go ahead and pause the video, give this one a shot, restart it when you are ready. Okay, so we have a tangent squared and a regular tangent, so a non-tangent squared, so that definitely cues some sort of factoring here. Now this one does not have 3 elements, so we aren't looking at factoring a binomial. In this particular case, we only have the 2 elements, so this is going to be some sort of Gcf factor. So, looking at these two, what do they have in common? They have in common a tangent 2x, or I guess you could pull out a negative 2 tangent 2x if you wanted to. So factoring out a negative tangent 2x, what am I left with in my first term? Well, I'd be left with the second tangent 2x, and in the second term, I'd be left with negative root 3. And so now I can set them individually equal to 0. Okay. So then dividing the negative over, we get that tangent of 2x equals 0. Adding the root 3, we get tangent of 2x equals root 3. And so then you'd be thinking through, okay, where does my tangent of 2x equals 0 between 0 and 2 pi? And you should land on 0 and pi. Both 0 and pi have a tangent of 0. Now, this one is 2x, so we have 2 rotations, so we now need to add 2 pi to both of those. Okay, so adding 2 pi to 0 would be 2 pi, adding 2 pi to pi would be 3 pi. So there's my second rotation. And then dividing by 2, we have x equals 0 divided by 2 is 0, pi over 2, pi, and 3 pi over 2. Okay, as for the tangent of 2x equaling root 3, what reference angle are we talking about there? Okay, well the reference angle who has a tangent of root 3 is pi over 3. And then tangent is positive here, so not just the first quadrant, but also the third. And so that would be 4 pi over 3. And then we have 2 rotations, so we need to repeat that rotation another time. This is one rotation. We're going to now add 2 pi to both angles to get that second rotation. And so adding 2 pi to pi over 3, we'd be at 7 pi over 3. And to 4 pi over 3, we'd be at 10 pi over 3. Dividing 2 through then, we would have pi over 6, 4 pi over 6, or 2 pi over 3 if you were to reduce that, 7 pi over 6, and 10 pi over 6, or 5 pi over 3 if you were to reduce that. Okay? And that's objective 6. Okay, last but not least, we have a couple of additional simplification problems that come out of your objective 7 notes. So this would have been the assignments that you did last Thursday, Friday of last week. Let me pull that up just to make sure that I'm looking at the same thing you are, because we cut a couple of rules for this year. Okay, so if you're looking at your objective 7 notes, you'll see up at the top all of the double angle formulas that actually do exist. There is a double angle formula for sine, cosine, and tangent. But for this year, with the school closer, we've decided to focus in on the sine one, making sure we've got that down. And so Mrs. Pape did this notes video. She walked through why the sine double angle theorem works, showed it within the context of sine alpha plus beta. And so you don't have to have it memorized as long as you can derive it when the time comes. You do need to make sure that you are able to recognize your double angle formula for sine. Okay, and so we've got 3 problems here. Not all of them are going to use the sine double angle, because again, we do need to make sure we're thinking about it, although most will. Okay, go ahead and pause the video, give this one a shot, and restart it when you're ready. Okay, so for this first one, determining what our formula is going to be. In this particular case, this one is our sine double angle formula. So the sine double angle formula again, sine of 2 theta equals your 2 sine theta cosine theta. We're going obviously the reverse direction, and so in order to apply our rule here, we do need to first see this 2 sine theta cosine theta. This currently says 8 sine theta cosine theta. So how could I rewrite this 8 so it's 2 sine theta cosine theta? I could rewrite this 8 as 4 times 2. Right? And now it matches to sine theta cosine theta, so my theta is 4 pi over 7. The 4 is just going to be a coefficient, so it's just going to hang out. And 2 sine theta cosine theta equals sine 2 theta. And so this is equal to sine 2 of my thetas, 4 pi over 7, which is 4 sine of 8 pi over 7. I cannot simplify this one, so that's my answer. Okay, go ahead and pause the video, give this one a shot, restart it when you are ready. Okay, so formula. This one again is our sine double angle formula. Now this one is a little bit kind of wonky looking at first, but it's not impossible to manipulate. First thing, the nice thing about product is you can switch the order of the product and not worry about it. 2 times 3 is the same thing as 3 times 2, so it's like the addition where we can just switch them if we'd like. You can't do that with subtraction and division though, right? 2 divided by 3 is not the same thing as 3 divided by 2. Or 2 minus 3 is not the same thing as 3 minus 2. But addition and multiplication we can just switch. So we're good to go there. We can see our thetas. The only other thing we need to see is the 2 out front, because this says 11. And so we need to somehow figure out, well, what can I do to this 11 to get it to be 2 sine instead of 11? Okay. Well, if I multiply it by 11 halves, the 2's will cancel, and I'll have 11 sine 3 theta cosine 3 theta. Okay, so that 11 halves is a coefficient. We're good to go ahead and combine. 2 sine theta cosine theta, 2 sine theta cosine theta equals sine of 2 theta. Sine of 2 times my theta, which is 33 degrees. So 11 halves, sine of 66 degrees, which I do not know what the sine of 66 degrees is, and so that's my answer. Okay, last but not least, go ahead and pause the video, give this one a shot, restart it when you're ready. Okay, so for this one, a couple of different first steps that you could take if you wanted. For me, I'm going to go ahead and get rid of the negative angles. So negative angles were in your notes. I know initially they were in there in Objective 2. I think they were also in there in Objective 3. That's what I'm double checking real quick here. Yes, they are written in both your Objective 2 and your Objective 3 notes. And so you can reference either one of them. In this particular case, I apologize. There's an error in this problem as I'm looking at my answer key. I had meant to write a different problem down. So let me go ahead and cross that one off. I will give you another one to kind of hit on another element within the problem I had meant to write down. But let me go ahead and fix that error real quick and give you a new problem. Actually, this will probably be the fastest way to correct this. And then again, I'll give you another one. Okay, sorry. Go ahead and pause the video, give this one a shot, restart it when you're ready. Okay, so for this one, ladies and gentlemen, we are looking at simplifying using, there we go, using our cosine squared plus sine squared rule. Now this is not initially in cosine squared plus sine squared. However, if I factor my -3 out here, I get cosine squared x plus sine squared x. The nice thing about cosine squared plus sine squared is that is 1, and -3 times 1 is -3. Okay? Okay, last one. Let's go ahead and do this guy. That way we can hit one of the other rules I had wanted to hit on the previous one. But yeah. Go ahead and pause the video, give this one a shot, restart it when you're ready. Okay, cosine of pi over 2 minus x. Cosine of pi over 2 minus x is your complement from Objective 3, where that's written in. Cosine of pi over 2 minus x is the same thing as sine x. Okay, in Objective 2 and Objective 3, we wrote down our opposite angles. And so looking at your opposite angles here, this is linked to sine of -x. In fact, if I wanted to, I could rewrite this as times 1 over sine of -x if you prefer to think of it that way. Okay. But this is linked to sine of -x, and sine of -x is the same thing as negative sine of x. And so then simplifying this, sine x divided by cosecant x, I'm going to pull that negative off to the side, dividing by cosecant is the same thing as multiplying by its reciprocal. And its reciprocal is sine x. And so sine x times sine x is negative sine squared x. Okay? So these two are the ones actually from Objective 7. This is to just look at two other types of simplification. Okay? Okay, let us know if you have any questions.